Hi boys and girls, I'm Mrs. Conrad and I have a little science investigation for you to do at home. I know you've been studying about the 7 continents and the oceans and landforms and bodies of water, and you've talked about freshwater and saltwater. So that's what I want to talk about with you today is freshwater and saltwater. So you might already know that examples of freshwater are rivers, lakes, ponds, and examples of saltwater bodies of water are oceans. So why are oceans salty? That's kind of what I want to talk about. Why are oceans salty and rivers are not? So I have a little map behind me. I just drew all the rivers, major rivers in the United States, and I was noticing how they all run, or most of them run, right into the ocean. And that's true for rivers on all the continents in the world. All these rivers flow into oceans. And although rivers aren't really salty, they actually do have small amounts of salt in them. Scientists have new technology that allows them to really measure teeny tiny amounts of things, and they have found that rivers do have tiny bits of salt in them. And the reason why is that their salt is a mineral found in the earth, found on rocks and in soils. So when the water in rivers run over the rocks and the soil and the land, they pick up different minerals and carry those minerals with them, including salt, but it's just a little amount, but all that salt runs into the ocean. And so you've got salt coming in from all the rivers on all the continents, bringing minerals such as salt with them. And then the water in the ocean doesn't just stay in the ocean. Water in the ocean evaporates. All water all over the world evaporates. The heat from the sun turns it from a liquid into a water vapor. So if you've ever, like a puddle outside after it rains, it doesn't just stay there forever. Eventually, the heat from the sun turns it into water vapor and it evaporates up into the sky. So I want us to ask ourselves this question, and this is what we're going to be investigating today. Does salt evaporate? Does salt turn into a gas and evaporate up into the sky? Does salt water evaporate? So we're going to kind of look at that today. So to do this at home, here are the materials that you are going to need. Make sure you watch my video first, and then you can rewatch it again if you're doing it at home. You're going to need 2 containers. It could be 2 cups, 2 bowls, 2 Tupperware containers, just 2 things that will hold a little bit of water. And you need water, so I have some water here. And you're going to need some salt, and you're going to need a spoon, and then we're going to need some measuring tools. So as you see in the science lab, I would use a beaker, but since you're at home, you probably have a measuring cup, and you're going to need a measuring spoon, or a spoon like this could work as well. And then you may need a marker or something because we want to label our cups, okay? So that's what we're going to do first. If you have a container that you can write on it, you can label 1 salt water and 1 fresh water. I went ahead and put mine on tape so that I can reuse these plastic cups. So I have one that I'm going to write salt water on, and then I have one that I labeled fresh water. So I'm going to put that right here. Okay. And now we want to put water in each of them. So I'm going to do, I don't want to do a whole lot of water. So I'm going to do 1/4 cup. Okay, so make sure we measure liquids like a scientist. It's a little bit different than maybe you would do it in your kitchen, but you want to make sure your measuring cup is flat on the counter, and you want to get down eye level, and you want to pour. Scientists need to be very precise, so I'm going to make sure I get it right at 1/4 cup. I'm going to put 1/4 cup of water into this cup, and I'm going to put 1/4 cup of water into this cup. Okay. Next, I'm going to add salt to my cup labeled salt water. So So I just have a half a teaspoon. So since I don't have very much water, I don't need very much salt. So I'm just gonna do half a teaspoon. Yep, that's about right. Put half a teaspoon in there, and then I'm going to stir. And okay, second graders, I cannot let you get away from a science lab without talking about properties. Every time you come into my science lab, if you don't already know, we talk about properties. Properties are how we describe everything around us, and scientists use properties all the time, right? So properties could be color. So these are both pretty clear, but you can see now the salty one is a little cloudy. I wonder if it'll stay cloudy. As you make observations, you'll have to see if it stays cloudy. They're both liquids. We have the same amount. They probably feel the same. The texture probably feels the same. They will taste different. Do not taste these, boys and girls. This is science. We do not put things in our mouth in science, so do not taste it. But you should know salty in water is going to taste salty. And you've probably tasted salty ocean water before. Okay, so we're just going to now, I want you to set these cups in a window. And I want you to make observations. I want you to keep your eye on them. Watch them as the water evaporates. So you should see the water levels kind of going down because a lot of the water is going to be turned into gas and evaporating. And keep your eye out. Is the salt in the salt water going to evaporate? And write this in your notebook. You know, be a scientist and draw it and write down your observations and draw what you see, and then let me know, or let your teacher know what you observed when you find out. Did the salt evaporate?